Welcome to the explainer on correlation and regression. As usual, we start with questions. So, the first question is, what is correlation? So, the correlation is a measure of the strength of the relationship between two variables. The two variables it could be the same variable but measured twice in the same sample of people. It could be two different variables measured in a group of people, or it could be any of these possibilities, but not in the same group of people, but in a group of people, in two groups of people, but those two groups of people are associated. For example, could be parents and offspring, and this is the research that Francis Galton did. Each parent is associated with an offspring, and so the height was measured in the two occasions. Sorry, in one occasion in each of these groups, but the groups are associated. So you can take a measurement in one sample and the measurement on the other sample, and you can associate those. In the cases in which you can do that, then you can use correlation. The other characteristic of correlation is that the two variables or two measurements of the same variable must be numerical. Okay, one way of representing a correlation is with a scatter plot. So in a scatter plot, you've got the observations, and the observations are represented by dots, and those dots represent the score of one participant in one of the variables and the score in the other variable as well. And one way of understanding what's correlation in these cases is to generate one line that minimizes the distance between these observations and that line. So it could be infinite number of lines, but there is only one that reduces the amount of distance has the minimal amount of distance between the observations and that line, and that would be the regression line. And the second question is, what is your understanding of the correlation coefficient calculation? Okay, so in order to measure the strength of the relationship, so before I show you a visual representation, but then we need a number that tells us about the strength of the relationship of these two variables, and that number is the correlation coefficient developed by Carl Pearson. And the correlation coefficient goes from -1 to 1, and 0 means that the two variables are not associated at all. 1 means that there is a perfect positive association, and -1 is that there is a perfect negative association. And values in between 0 and 1 or 0 and -1 they determine the strength of the association. Values close to 0 means that there is a weak association, and if the R-score is close to 1 or -1 means that there is a strong association. What does it mean, negative and positive? Well, positive means that if one variable, the values in one variable go up, then the values of the other variable go up as well. And negative correlation is that if one variable values go up, the other variable the values go down. And at the beginning, Galton only identified the positive correlation as the correlation, but then it was realized that negative correlation is also useful. And well, you may think, well, why is it useful if one goes up, the other goes down? Well, you can make a prediction of the values of the other variable, even though if it goes in the same direction. You can establish the relationship between the variables, and it doesn't matter the type of variable you use. Like, for example, you may think that increasing practice reduces error, or increasing practice increases performance. So if the relationship is with increasing performance, this is a positive correlation, because the more you practice, the higher your performance. But if you take into account error, the more you practice, the less error. And perhaps you can have a very good, a very strong association, but you're going to see that one goes up and the other one goes down. And in terms of the calculation, we've got the calculation in the population and the calculation in the sample. In the population, the correlation coefficient would be the rho. This is the rho, the Greek letter rho, and it's calculating the covariance of x and y in that population, and then the product of the standard deviation of x and the standard deviation of y. The correlation coefficient in a sample is exactly the same, but instead of using the covariance in the population and the standard deviations in the population, we use those in the sample. Now, I'm going to show you the formula of covariance, which is here, and I don't want you to worry too much about this formula, but I want you to try to understand why this formula will create positive values if the correlation is positive, and negative values if the correlation is negative. Okay, so think about it. If this is, if in the x-axis we've got one variable and y-axis we have another variable, then if the values in x go up from left to right, then the values of the y variable have to go up from bottom to top. So you expect a line that goes like this. Now that line always have to go through the mean of the two variables. So this is the mean of x and this is the mean of y. So any regression line has to go through that intersection between the two means. Now, if your values are in this diagonal that goes from bottom left to top right, then you expect to have a lot of positive values in the covariance. Why is that? Well, look at the covariance calculation. You've got the sum. So when we got this Greek letter sigma, means that it's a sum. What do we sum? Well, the difference score from the mean. So for each value in x, we subtract the mean. So values that are less than the mean now will become negative. The mean will become 0. And values above the mean, they will become positive. And those are multiplied by, for each participant, so for each participant we've got a score x and a score y. So we do the same with y, the y score of each participant. We subtract the mean of y. And again, if the value is higher than the mean, it will be a positive value. If it is lower than the mean, it will be a negative value. And if it is the mean, it will be 0. So what we need to do is to multiply those values. So one participant, let's assume the mean of the two variables is 50.